by setting it equal 150 over cosine 33.69, which gives us a value of 180.28. And remember the total force, I actually drew this arrow wrong. You have to be careful with your arrows. So it's a total force in that direction. So this needs to oppose the force pulling that way by pushing back that much. And we already calculated it's 180. And it needs to balance itself out with the arrow going in the other direction. So we have solved all but 2 of the beams now. But these 2 beams are the most annoying. So this one has 2 unknowns. This one only has 1 unknown. So we're going to do this one first. So what we're going to do is we're going to calculate the net force of y that is acting on this beam, and then we're going to set the y component of this beam equal to that. And the net force at that beam is going to be 466.67 up minus the y component here, which is we already calculated to be 400, and that is going down, which is why we're subtracting it, and then plus the y component of 180.28, which is calculated somewhere on my sheet of paper if I can find it. Someone with a calculator, can you type in 180.28 sine 33.69?
Yeah, like 100 or so.
Okay, yeah, that seems, oh yeah, I had 100 written down. I just didn't think that was it because it seemed like a good number. Okay, so, and then plus another 100, which is going up. And so this is going to be equal to a total amount of force of 366.67 up. No, sorry. 166.67 up. So now we know that this beam has to have a y component of 166.67 up. And so the sine of its angle, which is 12.59, is going to be equal to the value of its hypotenuse over its desired y component. And so the hypotenuse is going to be equal to 166.67 over sine of its angle. And that gives us a value of 768.29. And now we need to go back and remember the sign. So this is a total force going up. So our force needs to go down at this corner. And it needs to balance itself. So now that leaves us just one beam left. And so once again, we are going to calculate the total y force acting at a corner. You could calculate it at either corner. I'm going to calculate it at this corner. So you know that the value, this part exists, but it's irrelevant because it has no y component. So there's a total of 533 going up. And the y component of this, remember, we calculated is 166.67. So the total y force that this needs to have going down is these two added together, which is 700. And then we balance it out. And that is the problem solved. I don't know, come yell at me if you have any questions.